How can we manage variable discharges? What do you think about the main factors that could cause a change in the water discharge along a river? This phenomenon is due to the incoming and outgoing discharges. We will learn techniques to model and quantify the reality. Those discharges could be concentrated sources like a tributary that joins a main channel, which increases the overall discharge. On the other hand, a lateral wave along a river can decrease the volume of water in the main channel. Furthermore, there are distributed sources like interchanges with the groundwater. What is the problem? The problem is to understand what is the behavior of the flow in the main channel. Ultimately, we need to calculate the water depth that varies with the discharge. First, we need to establish the scale of the analysis, because the problem can be analyzed both globally and locally. The global scale is a problem treated by hydrology. However, we will focus our attention on the local scale, which considers only a short river reach and only one incoming or outgoing discharge. By doing so, we can better manage the problem by only changing the typical local hydraulic parameters. In general, to solve the problem of variable discharges along the river, we can use a balance of energy or a balance of momentum. In the case of incoming discharges, there is a dissipation of energy, which is difficult to quantify. Therefore, we use the balance of momentum. In the other case, the energy balance is used because energy losses are negligible in the main channel during the process of outgoing discharges. Let's focus our attention on the incoming flow. When we know in advance the amount of incoming discharge, we can estimate the change in water depth. On the other hand, when we deal with outgoing discharges, the water level in the main channel undergoes a sharp variation. In this case, we do not know the amount of outgoing discharge, but we will learn the techniques to deal with such cases. In addition to those topics, we will develop an understanding of accelerating and decelerating effects of variable discharge and learn how to utilize them to train the river. An example of this utilization in real cases can be as follows. In the case that the incoming water volume is more than the channel capacity, we can have flooding as seen in the picture. One of the possible solutions for this problem is to increase the cross-section of the channel. An alternative way of reducing the water height can be the creation of a system of diversion in order to redistribute the discharge. In conclusion, the spatial variability of the incoming flow is sometimes too high and unpredictable because it is dominated by natural causes. As you can see, this problem is relatively complex, and this is why we consider a small reach for our analysis. Fortunately, we have at our disposal at least two equations that we will learn how to effectively apply in the most suitable cases.